revisit our trig identities. I'm not gonna belabor the point on the introductory ones because we've already gone through those Pythagorean identities. Okay, we've used those over and over and over again. They are worth mentioning again. Here they are in blue. Those are the key Pythagorean identities. We use them a lot, and we'll continue using them. All right. The other identities, the ones that we've come up, which resulted uh, from the graphs and their symmetry, sine of a negative angle is negative sine of an angle, cosine of a negative angle is the cosine of an angle, and the tangent of the negative angle is the negative tangent of the angle. The cofunction identities that we talked up very early, okay, or else which could be, it could be viewed in terms of phase shifts on the graphs if you want it. Okay, either way, the sine of pi over 2 minus x is the cosine, and cosine of pi over 2 minus x is the sine. We'll use those. We're calling on a bunch of these to develop some of our new identities. Okay, these are identities of course that have been light has been shed on because of the periodic nature. You're just shifting the function by its wavelength, so it comes right back onto itself. Now here's a new one, the angle addition, the addition formulas for sine and cosine. Now we're going to have to ask you to just accept this one on face value, okay? And then this is going to be used as a building block for defining the others, okay? So there are proofs for this that your book does outline. If you can prove one of them, then the others kind of follow as a consequence. And so we're going to forego that rather long geometric proof for the basis of this and kind of accept that on blind faith and move on with it from there. So sine of a plus b is sine a cosine b plus cosine a sine b. And on that basis, we're going to say, well, can I come up with, from that, can I come up with the one for the sine of a minus b? And yes, of course you can. Because we can and should realize, of course, that subtraction is addition of the opposite. So therefore, a minus b is nothing more than a plus negative b. So I'm going to say, then, why can't I come up with a new identity for sine of a minus b by building it off of my existing identity that the sine of a minus b is nothing more than the sine of a plus the opposite of b. And on that basis, I can come back and just use this. So that's exactly what I'm going to do, as you'll see. Okay, so the sine of a minus b is the sine of a plus the opposite of b, which I mean to come right back up to this and just replace a with a, b with b's opposite. And now I have a couple things here to happen. Of course, these call on some earlier identities, which were reminded here, the opposite angle identities. The sine of the opposite of x is the negative x, the negative sine of x, and the cosine of the opposite of x is the cosine of x. So incorporating those into this statement up here, we come up with the new identity for the sine of a minus b. The sine of a minus b being the sine of a cosine of b minus cosine a sine b. All right. And now we're going to recall these cofunction identities that were introduced very early when we just first started talking about sines and cosines. Okay, and so we're gonna call on those to build up our identities for the cosine. So I could always say that if I wanted to find the cosine of a plus b, I can simply say that the cosine of the angle is the sine of its complement. That's exactly what these are saying up here. The cosine of the angle is the sine of its complement, okay? So what is the cosine of a plus b? It is the sine of the complement of a plus b, which is simply, okay, pi over 2 minus the collective quantity a plus b. and I'm just going to reorient that a little bit to read, as you can see up here, sine of the pi over 2 minus quantity a plus b is going to be read as pi over 2 minus a closed quantity minus b. That's perfectly legal in doing that. So now I'm going to build I'm going to build my cosine of a plus b on this basis right here. So we're recalling this sine of one angle minus another angle. So here we go. So the cosine of the quantity a plus b is the sine of the collective quantity pi over 2 minus a minus b. All right, which now we're going to just call on this formula is the sine of the first, the cosine of the second, minus the cosine of the first, sine of the second. Okay, and now by definition, we'll realize that the cosine of pi over 2 minus a is what? The sine of that angle a. Okay, and the cosine of pi over 2 minus a is the sine of that angle a. So that arrives at our angle form for the cosine. Of course, we said the cosine is easy to remember because it spells its name out. Cosine, cosine, opposite, sine, sine. And likewise, we can come up with the building up the cosine of the angle difference by recalling, much like what we did earlier for the sine, that a minus b is nothing more than a plus the opposite of b. And on that basis, we come back to this. We replace b with its opposite, and then recall what the cosine of a negative angle is simply the cosine of the angle. So that comes down. The sine of the negative angle is the negative sine. That negative brought across will make this a positive. Okay, we're going to terminate it here, pick up with another video, talk about the half angle and double angle identities. Okay.